What if a super-Earth existed in our solar system? What if our solar system wasn't as perfectly balanced as it is today? Imagine a massive super-Earth occupying the asteroid belt between Mars and Jupiter, disrupting the gravitational harmony that keeps everything in place. Would Earth still be a thriving haven for life? Or would it face a grim fate? Scientists have run simulations to explore this very question, and their findings reveal a reality filled with unexpected possibilities and potential chaos. The introduction of a super-Earth into our solar system could alter everything, from the orbits of planets to the stability of Earth's climate. But just how big of an impact would it have? Would life as we know it even be possible? Our solar system, a rare cosmic structure. Our solar system is a delicate dance of planets, moons, and celestial bodies, all held together by gravity and inertia. Compared to other star systems across the universe, ours is unique in one very important way. It lacks a super-Earth. A super-Earth is a planet larger than Earth, but smaller than a gas giant like Neptune or Jupiter. These massive rocky worlds are incredibly common throughout the universe, appearing in a vast number of exoplanetary systems. Yet for some reason, our solar system never developed one. Instead, we have the asteroid belt, a collection of rocky debris orbiting the Sun between Mars and Jupiter. But what if a super-Earth had formed in the place of the asteroid belt? Would the solar system still look the way it does today? Could Earth have survived such a cosmic shift? Recent research conducted by planetary scientists Emily Simpson and Howard Chen from the Florida Institute of Technology aims to answer these very questions. Modeling the impact of a super-Earth in the asteroid belt. Simpson and Chen's study explored how the presence of a super-Earth in the asteroid belt would have influenced the solar system's stability. Specifically, they wanted to see how such a massive planet would affect the orbits and axial tilts of Venus, Earth, and Mars, key factors in determining a planet's ability to support life. Using advanced computer simulations, they placed hypothetical super-Earths in the asteroid belt and observed their effects over millions of years. The planetary masses tested ranged from just 1% of Earth's mass to a staggering 10 times Earth's mass. The results? Even small changes could have major consequences. A smaller super-Earth, minor but manageable changes. In cases where the super-Earth was relatively small, around twice the size of Earth, the solar system remained largely stable. The inner planets, including Earth, continued to orbit in a way that would still allow life to thrive. However, there were some noticeable differences. One key effect was a slight change in Earth's axial tilt. The tilt of our planet is what creates our seasons, and even a small adjustment could make summers hotter and winters colder. This might lead to more extreme weather patterns, but nothing so severe that it would render Earth uninhabitable. According to Simpson, if it's 1 or 2 Earth masses, which is still a pretty big planet, our inner solar system would still remain quite nice. A larger super-Earth, a dangerous disruption. The real trouble began when the simulations introduced a larger super-Earth, one with 5 to 10 times the mass of our planet. These scenarios created major disruptions in the solar system's structure. The gravitational pull of such a massive planet would be so strong that it could destabilize the orbits of nearby planets. In some cases, Earth's orbit shifted dangerously close to Venus, bringing it too close to the Sun. If this happened, Earth could be pulled out of the habitable zone, the narrow region where conditions allow liquid water to exist. Even worse, Earth's axial tilt became erratic in these scenarios, causing extreme seasonal shifts. Summers would become unbearably hot, possibly boiling the oceans, while winters could plunge the planet into deep freezes. Such wild climate changes might make it impossible for life to survive. In the worst-case simulations, Earth's orbit became so unstable that it was eventually ejected from the solar system altogether, drifting into the cold emptiness of space. The absence of a super-Earth, a blessing in disguise? Simpson and Chen's findings highlight just how fragile the balance of our solar system is. The absence of a super-Earth in the asteroid belt may not be a coincidence. In fact, it might be the very reason life on Earth has been able to thrive for billions of years. If a super-Earth had formed, it could have drastically altered the course of planetary evolution, possibly preventing life from ever emerging. The asteroid belt may actually be a lucky accident, one that gave Earth the stability it needed to support complex life. Implications for the search for life in the universe. While these findings are fascinating for understanding our own solar system, they also have important implications for the search for extraterrestrial life. Many exoplanetary systems feature super-Earths, often located close to their host stars. If these planets disrupt the orbits of neighboring worlds, they might make it harder for life to develop. By studying the impact of a hypothetical super-Earth in our own solar system, scientists can gain valuable insights into how planetary systems evolve. This could help astronomers refine their search for habitable exoplanets, focusing on systems where conditions are stable enough to support life. Could a super-Earth still form in our solar system? One question that often arises from this research is whether a super-Earth could still form in our solar system in the future. The answer is, thankfully, no. The planets in our solar system have settled into stable orbits over billions of years, and the chances of a new planet forming in the asteroid belt are practically zero. The only way a super-Earth could appear in our solar system would be if an enormous rogue planet entered from deep space, a scenario that is extremely unlikely. However, if such an event did occur, the consequences could be catastrophic. The gravitational disruptions would be severe, potentially altering planetary orbits and even triggering massive asteroid impacts, the fragile balance of the cosmos. This research serves as a powerful reminder of just how delicate the balance of our solar system is. Every planet, moon, and asteroid plays a role in maintaining the stability that has allowed life to flourish on Earth. Even a small change could have far-reaching consequences. As we continue to explore the universe, these findings deepen our appreciation for the cosmic conditions that make life possible. Our solar system may be an outlier, but it is also a rare and precious home, one that we should never take for granted. The final question: what if it had happened? So what if a super-Earth had formed in the asteroid belt billions of years ago? The answer is simple. Earth, as we know it, probably wouldn't exist. Life might never have developed, or it might have taken a completely different form on another planet. Simpson and Chen's research reveals that our solar system's current structure is not just a coincidence. It may be one of the key reasons we are here today. The absence of a super-Earth has allowed Earth to remain in a stable orbit, with predictable seasons and a climate that supports life. In the grand scheme of the universe, our solar system is an anomaly, one that has given rise to something incredibly rare: intelligent life. And that raises an even bigger question. If our solar system is so unique, how many others like it exist? Could there be another world out there, perfectly balanced like our own, waiting to be discovered? Only time and science will tell.